We want to be able to solve these systems of equations algebraically. So to do this, we need to make sure we understand the principles and properties that we are able to apply. So one of the things that we have to make sure of is the golden rule. What you do to one side, you have to do to the other. Okay? Or in other words, we have to keep it balanced. Okay? So that's really the only rule. We need to keep it balanced. And if we keep it balanced, we can do anything we want. So we do want to solve equations, so we want to make sure that these properties are clear. So for the first property that we're going to look at is that we can multiply or divide both sides without changing the balance. So you can double both sides, you can half both sides. If you do that, if we started with a balance, it will remain balanced. So for example, here I have 2b plus 6c plus 18. So I have 2 bricks, 6 circles, and 18 ones. If I take exactly half of this side and half of this side, so I have 1 brick, 3 circles, 9 ones, this is going to remain balanced. Okay, so 2b equals 6c plus 18 is balanced. 1b equals 3c plus 9 is balanced. In fact, they are the same. They represent the same proportional balance. So algebraically, it looks like this. If I have 7x equals 10 plus 2y, I can increase the left-hand side by a factor of 5. So I have 35 x's, and it will remain balanced as long as I increase everything on the right-hand side by the same factor of 5. So I get 50 and 10y. So again, everything on both sides has to be increased by or decreased by those multiplying or dividing factors. So that's property 1. Property number 2 is that if we have equations, we can combine equations and keep it balanced. So if we have two equations that are balanced, so here I have x plus y equals 2x plus 5, so algebraically it looks like this. And I have another balance, y plus 21 equals 2x's, so y plus 21 equals 2x's. I can group everything on the left-hand side together and everything on the right-hand side together, okay, and this will remain balanced. So if I add these two equations together, so I will end up with, on the left-hand side, 1x, 2y's, 21 ones. On the right-hand side, I end up with 2y's, 2x's, 5 ones. If they are balanced to start, they will remain balanced when we combine them. So that is the second property, and that applies also for subtraction. If this equation is balanced and this equation is balanced, what I can do is I can subtract these two equations from each other. So what ends up happening here is I end up with 6 minus 5x's. So I end up with 1x. 3y's minus 3y's gives me 0y's. 15 minus 13 gives me 2. And in this case, I started with two variable system and I ended up with a solution for x. And in fact, this is the idea behind systems, that we want to eliminate one of the variables so that we can isolate the other variable, and then we can solve for, once we solve for one variable, we can substitute back in to solve for the other. So we're going to use these properties then to help us eliminate one of the variables to help us solve systems.